Find the limit. The limit of cosine of x divided by 1 minus sine of x as x approaches pi over 2 from the right. Typically what we would do is we'd try our quotient rule. So we would take the limit of the cosine of x as x approaches pi over 2 from the right, divided by the limit of 1 minus sine of x as x approaches pi over 2 from the right. The cosine of x is a continuous function, so we can calculate the limit by substituting in the number. Same for 1 minus sine of x. That's a continuous function, so we calculate the limit by substituting in the number. The cosine of pi over 2 is 0. The sine of pi over 2 is equal to 1, but then 1 minus 1 is 0. So we get an indeterminate form, 0 divided by 0. Cosine of x and 1 minus sine of x are both differentiable functions. And so we can try to calculate this limit using LHopital's rule. So by LHopital's rule says that you can take the derivative of the numerator. So we're still taking the limit here as x goes to pi over 2 from the right. The derivative of the numerator is negative sine of x, divided by the derivative of the denominator. The derivative of 1 is 0. The derivative of negative sine of x is negative cosine of x. Now when we try to do our quotient law, of course the negatives will cancel. We would again do the limit of the numerator. That's a continuous function, so we get limit of sine of pi over 2, divided by cosine is also a continuous function, so we substitute in the number. So we have the sine of pi over 2 divided by the cosine of pi over 2. Sine of pi over 2 is 1. Cosine of pi over 2 is 0. So this tells us that this limit is not going to exist because the denominator is 0, the numerator is not 0. So we're going to get some variety of infinity here. We have to know what the value of sine and cosine are close to pi over 2. So if x gets close to pi over 2 from the right, that means that x is a little bigger than pi over 2. And if x is a little bigger than pi over 2, then we're going to be in the second quadrant. And the sine of x in that case is positive. The cosine of x is negative. So actually, we have the numerator getting closer to 1 from below, the denominator also getting closer to 0 below. That means it's a negative number. So we actually have a positive number divided by a negative number, which gives us negative infinity for our limit.